Okay, so I'm starting to build my diff. The first thing I'm going to do is degrease and de-wax the entire inside of this case, down both tubes, especially in the center section, and then back where the pinion comes through. So it's super important to keep these bearing caps marked. They're side specific, so you can't put the right on the left, left on the right. At least you shouldn't. So I've taken a little paint pen and marked this one. It was marked previously, but I figured throw a new mark on it just to be good, just to be sure. So first thing I got to do is down here, I need to punch out these old bearing races. So I'll start with this one on the front. I'll flip the diff around and then I'll, from the front, punch this race out. Okay, so I got the factory races beat out of this case, and after reading the instructions, one thing I'm missing is Loctite 638, a retaining compound for attaching the ring gear onto the carrier. So this is the carrier, it's the center section of the diff, that's what the axles attach into, and this big ring gear here will actually bolt onto it. So in the instructions they say to put the Loctite 638 retaining compound on here before fastening it to your carrier. So I'm going to need to pick up some of that. I also don't have a bearing press here, so I can't do this myself. I'm going to go down to a friend's shop and do that, so I don't know if I'm going to have any video of that process. But essentially what happens is you put the Loctite on the ring gear, and then the ring gear is going to press down onto the carrier. I'm not sure how well you can see it, but there is this lip here, and that's what the ring gear presses down onto. So I got this diff pretty much as it sits right here. I threw the primer on it, but I did get it with nothing. No gears, no center section, nothing. So I'm going to be setting this thing up from scratch. I did a lot of reading today, and on the pinion, typically you're going to have a shim between the pinion head and then the bearing which goes on it. Since I don't have a pinion that came out of this, I don't know what shim was used stock, but the pinion shim that I'm going to start with is 30 thou. It seems like for the Ford racing gears, that's a good all-around starting shim. It's not gonna, I can always change it up later. Once I get the center section in and I start measuring pinion depth and I look at the gear pattern, I can change that out, as I need it. So the next part of prep I can do on the pinion is I can get the setup bearing going. So the bearings on these are press fit for final install. So what that means is that if I take my pinion bearing here, this bearing does not just slide all the way down. When this is fully installed, it's going to be mated right up to the head of the pinion here. So this is press fit. So for my setup, what I want to do is I bought a second bearing. And what I'm going to do is I'm going to take my carbide bit. I'm just going to bore out the center of this a little bit. I'm just going to chew it up so that the inside diameter is a little bit bigger. And that will allow this bearing to freely slide on and off, so that I can change that shim out if I need to. And then when I go to do the final install, I will press my good bearing, which came in my kit, which is in one of these boxes here, my outer pinion bearing, or my inner actually. But I'll final fit and I'll final press that one on. So this one, I bought this as a second bearing when I bought all the parts for the install, knowing I was going to cut it up and chew it up. Okay, so I got my setup bearing, so it just easily slides slides on and off the pinion bearing now, or the pinion. Is these bearings need to be pressed onto the carrier. As you can see, it doesn't just slide down. These are press fit. So when we're pressing these bearings on, we don't want to have any pressure on this cage or the bearings themselves. What we want to do is get as much of the pressure onto this middle piece, because this is solid, as we possibly can. So if we were to just press this down, you're potentially putting pressure on the cage, and that's going to damage the bearing, which is what we don't want to do. So what we're going to do is we're going to take an extra bearing that I bought, and what I'm going to end up doing is on these second bearings is I'm actually going to cut the cage, pull all the bearings out so it's just the center piece left. Okay, so since I last left you, pressed on these carrier bearings on both sides. So now you can kind of see what I was talking about before when we were pressing the bearings on, that we use this cut up bearing to press down on the top. And then when we're pressing this down, the cage can still spin freely, and we're not going to damage any of the actual bearing surface or the cage at all. So when we started, obviously there was no bearing on the bottom side, so we just had the carrier resting on the press plates. Put the first bearing on, put the cut bearing on top, had a little seal and driver puck, and then the press was able to come down and press against this and press this bearing onto the carrier. We pressed it to between 5 and 6 tons of force, and it's completely bottomed out on the bottom side. What we then did to press the second one is we had, again, a cut bearing on the bottom side. We placed the carrier until it fit nicely and this bottom bearing can spin, like so. Place the second bearing just on top of the carrier. Had our second cut bearing, put it on top. So now when we're pressing the second bearing on, again, we're not damaging the carrier on the bottom bearing or the bottom bearing, and we're not damaging the top one. So you press this down. Again, we press it to 5-6 tons, between 5 and 6 tons of force. It's bottomed out. We also lubed just on the inside of the carrier and the inside of the bearing a little bit with some 80-90 just to help it slide down. Yeah, so that's how we got the bearings on. So the next part was to make the ring gear to the carrier. Now what we did for this is on the press, we had a couple blocks of wood on either side, a 4x4 and then a 2x4 on top of that. And, put the ring gear essentially on top of that. Use 2 bolts to start guiding it as per Ford's recommendation. And then we took our cut up bearing, put it on top, and then with the wood here, we were able to press this carrier onto the ring gear. Once that was all pressed on, we torqued these up to 40 pounds, and we torqued them up to 70 pounds, and then we torqued them up to 100 pounds. Wow, was that a chore. 100 pounds of torque was rather difficult. What we ended up doing is taking a pry bar and putting it between the bolts, holding it down, and then the second person could actually torque it. And it still took quite an amount of effort to get them. So we torqued them to 100, and then we just did it again just a second time just to make sure, torqued and retorqued, as my friend would say. Yeah, so now I have my carrier all ready to go, and we can start building this diff. One of the first things I need to do is I need to drive the inner pinion bearing race into the housing. So this is what it looks like. I'm going to take a little bit of the 80-90, on the outside, put a little on the inside here. And what I found is I bought this sealing driver kits. And the 76 millimeter, it doesn't quite line up. Like, this is not angled to match the race. So what I'm going to do is I'm going to take the largest size, which is way oversized. Again, it does not fit in there well. If I hammered on this, it's going to damage the inside of this race, which I absolutely do not. This should be a perfectly smooth surface. So I'm going to flip this around on the tool so that it's the flat side and flat side to the race, and then I can pound this in. And then what I'm going to do is flip this around, and on the outer pinion do the same thing. Probably just grab one of these, flip it around on the handle. So anyways, be on the handle like this, and punch it in that way. I don't have one of these pinion seal pucks that's going to fit this inner pinion race very well. So what I'm going to end up doing is using the old race, put it up against the flat, and then take one of these that's a little bit bigger, put it on top, and then use this to drive it in. So yeah, this one's slightly too big, and this one is like the exact width of the, maybe this one will work. Yeah, no, this one's not going to work. It doesn't even go in at all. And then this one's way too small. That's, no, that's not going to work. So, old race, puck, let's go. This one's going in a lot easier than the inside race went in. So I actually had to switch down to a smaller pucks that will fit inside so that I can bottom this out. And I'm going to keep recording so that you can hear that the sound changes when the race gets bottomed out. So I hope you heard that. This race is fully bottomed out. We have 2 installed races. I contacted Ford Racing because I found different information online about how thick these shims should be to start from scratch. Originally when I set this up, I grabbed 2 16s to make 32,000, but Ford Racing tech line, I spoke with a gentleman named Tom there. He said flat out 28 thou is how we're going to set it up. So it's going to be a 16 thou shim and a 12 thou shim. So I know these 2 are 16, so I can toss one over and then find one of these that are 12 using my digital calipers. Zeroed. That one feels pretty thick. I'm guessing this is going to be a 12. 12 thou on the dot. So that was a 16. Put these together, make sure we're 28. Reading 29. That's odd. Not what I would expect. Ooh, let's not destroy this. 16.5. 16 flat. I think this one was 12 flat, right? Yeah, 12 flat, 16, 28. Zero, 0, 2/8. Just gonna clean this off a little bit. Use a little bit of brake clean on there. It's looking kind of dirty. Just clean off our shims. Okay, 28th out, that's where we're starting. So the next piece to this puzzle is I'm not using a crush sleeve. I'm using a solid pinion spacer. And the Rechecking instructions say, typically what you would do is you would measure your old crush sleeve, and then you would get the solid pinion spacer roughly at the same crush. But the Rechecking instructions say if you are starting from scratch, start with 3 shims. So 3 shims. Before I put that on, I actually want to put my setup bearing on. Got setup bearing, solid spacer and shims. I don't know if it matters which way the shims go, but I don't like that because there's a bit of a lip on the back side, so I think I would rather have a solid spacer and then the shims. So it looks to me like this pinion flange has its own seal. This is off an 0304 Cobra, so I'm not sure if I actually want to install Ford Racing seal. It would typically go on here. I just don't. Okay. So that is so the seal is going to get installed. Like the seal does fit inside here just fine. So I am going to, I'm not going to install the seal yet, and the reason being, I'm going to have this pinion flange and the bearings on and off a few times while I try and, or while I'm setting up the gears. So I want to save the seal until the end. So this goes in, and so next is the oil slinger, which I got some new colored gears. Boom. So you throw a little bit of oil on the lines. Okay, so I got the pinion bearing, the oil slinger. I put some oil on the threads for the flange, and some oil on the bearing. Yeah, so carefully put this in from the bottom up. That's odd. Okay, well, this is where we gotta stop and go and do some research because that does not seem right. I would expect this bearing to slide right down to essentially the solid spacer. So since it's not, I gotta go either watch some videos, like figure out what exactly is going on. Okay, so where are we at? This bearing, let's drop down on the pinion a little bit more freely than it is right now. This measures in at 318 thou, and this is 1.308 thou. So I need 8 thou off of this. Looked at a YouTube video, and I can scuff the pinion in this area with a little bit of sandpaper just to clean this up and get the coating off and get this down that 8 thou that I need. So I'll take the bearing off, take the shims off, take this to the other side of the shop. So while I'm sanding, I'm not getting like dust on the bearings and stuff. I want to keep this as clean as I can, given the working conditions. And then what I'll do is I'll clean it up over there, and when I come back, I'll re-put some oil on the splines. But yeah, so sandpaper the pinion bearing, or the pinion, down a little bit right in this area. Solid spacer is going to sit like so. So I don't need to go the entire length, but definitely want more towards the top here. And the reason why I'm doing this is when this goes together, we have this bearing sitting like this, and this flange comes on top. Right now, there's really not enough threads to get a nut on. So I took a little bit of 80 grit paper in here, and all it really did is take the coating off. It didn't actually get into the metal. I'm still at 1 and 314 thou. So I really didn't get anything off of it. And our bearing is of course still at 308, 309, depending on the measurement. So I think what I'm going to have to do is just, tighten this down onto it using the nut. And then if I do have to pull it out afterwards, I will just have to use a puller and pull it off. Not a whole lot I can do, unfortunately. I don't want to damage this. That's the last thing that I would want to do, is damage this. So I saw a little bit of dirt on these shims, so I'm just going to clean these shims off before I put them on. Make sure there's nothing on them. Bearing. Okay. Solid spacer and 3 shims. Well, let's see what we see. That's not really going over at all. Fuck! There's nothing I can do either. It's just... the only thing I can really do is... no, I can't even put that on one. I'm just not even getting any threads on that. Well, maybe I can flip this around and kind of fuck around that way. No, I don't do that. That'd be stupid. Washer's supposed to go, and this flange is supposed to go. No, so no matter how I slice it, this bearing has to sit down on this at least a little bit for me to at least even get this nut started on the flange. So the 80 grit sandpaper didn't really work, but I don't want to grind on this. So I'm just gonna try with the 80 grit sandpaper some more and see if I can get this down so I can really think to do. So I was trying to take this down just with sandpaper, and I cannot get it to move a thousandth of an inch. So I ended up using my air die grinder with a used up flap disc, and now this bearing is still tight. Like there's no play in it, but it does come on and off as it should. Now I can actually this setup bearing, this up in place, bearing, which now goes and sits next to the race, oil slinger. Do you want to put just a tiny bit of oil on these splines? Oil on the splines. There we go. Now we can flip this around, put this on top. And we can at least start our pinion nut. Look at that. Okay. A little bit of modifications. We were able to get that bearing on. Now, what I'm going to do is torque this. Actually, what I'm going to do is make a tool to hold this, and we'll torque this up to 125 foot-pounds, which is what's recommended by Rechecking, who makes the solid spacer. Once that's at 125 foot-pounds, we can flip this over and start working on the carrier. Just realized I put the solid spacer in. Whoopsie! So this has to come off. This next to off. Just put this on for a second. Got a stud blow hammer. Solid spacer on. Now we put this in. Now we put the bearing. Oil slinger. Our pinion flange. Okay, so I had this old bar from when I was installing my fuel cell. So I just drilled out a couple of the holes to 7/16, and then I just had to run out and pick up couple of washers and bolts because I didn't have anything 7/16 here, so I'm hoping this is right. A little loose. I'm not sure if it's actually 7/16. Might be half. I mean, for torquing it down, it should be okay, I think. Probably not gonna hurt it, I hope. Don't want to have to buy a new flange, but yes, this is just going like this. And like so. And we'll just give that a little bit of a tighten. Beauty. So now I should be able to torque this right up to 125 foot-pound. Let's just fix that 3/8 of this average. Oh, 125 foot-pounds. Holy shit balls. There's still some play in this though. There's still a lot of movement, which is quite odd. So I grabbed 7/16 by 20 volts, and these are loose in here and really not good. What I found out is these are probably going to be M12 by 1.75, not 7/16. So instead of going out and getting a couple of M12s, because when I buy the diff and the flange, I'll buy the bolts at that time. I thought to myself, what else can I do here? Well, Ben, let's not be an idiot. I take a couple of bolts, go on the back side. My bar and chop. Throw a few washers on this side. Make sure it's even on the other side. 3 and 3. A couple of nuts. Then what I should be able to do is draw these up, and Pinion should drop out. There we go. Alright. It's Pinion, bearing, and this guy. Okay, so the Rechecking solid spacer says you start with 3 shims, and it should be loose, which, as we saw, it was loose. There was tons of play in there. And what they say is you remove spacer and shims, reduce the shim pack in 2 thou thickness increments, and install until the proper bearing preload is achieved. So, what we need to do is figure out how many thou this pack here is. Okay, so we are 50. 46 thou. Let's call it. So I'm going to go 44 thou. I think I'm actually going to go to 40. I'm going to drop 6 thou right off the get-go because there was a ton of play in there. And yeah, there's this tiny little catch on this shim. So, I mean, the amount of play that I have in here, I'm expecting 0 bearing preload. Yeah, I got nothing. Shim. Hopefully we get her preload, otherwise I'm trying without that shim. See what happens, I suppose. Fuck, we are bang on 18. I never would have thought that it was supposed to be, you know, this tight, but you know, we're in spec. Beautiful. That is mint. Okay, preload's done. I can get some of this stuff put away. Okay, so I brought you close up so you can kind of see this. So all I'm doing is just rotating this and looking at where it is, and we're 18, 20. So we just want a constant pressure on this 18 inch-pounds. And you can go the other way. Yeah, 18 inch-pounds, 16 to 18. That is just dead on perfect. So now we can start on our center section. I'm going to keep these bearings left side, right side. I have this big yellow paint here to tell me that this bearing cap goes on this side, and then there's little arrows on the caps pointing out, so you know where they go. I'm going to do my best to keep the right cap on the right side, left cap on the left side. Is it strictly needed? I don't know, but I'm going to do it anyways. And I'm actually going to do my best to keep it way outside of the housing falling on. When I was talking before racing, as per the instructions, I'm going to start the carrier out at 0.265, I believe. goes is race goes on to bearing. Kind of on the inside, so. That's gonna be a bitch, I think. So I'm almost thinking 265 on this side too. I just finished making myself this nice little shim installer. All I did is took the shim, drew it out, ground it out, and so got the caps installed. Got some play in this, which I mean I don't know how much 8/10 that is, but it feels pretty good. Here seems to turn all right. So let's install some caps. Takes a bit of a workout, but you got her there. Okay, so what you're hearing here and seeing is just a tiny little bit of backlash, which is a good thing. It's actually what we want. There has to be a little bit of backlash in here. And I believe the backlash we're looking for is 8 to 12 thou. So they say backlash should be checked in 4 locations, 4 thou max variation. So let's go. I want 8 to 12, and this is clearly 16. Yeah. 16 thou. So what this means is that the ring gear has too much space between the pinion. So it's too far this way. So what that means is I need to take 2 thou out of here. Sorry. Take 2 thou out of this side, put it in this side, so that'll move the ring gear over. Okay, so 270 on the left, 260 on the right. And bang on 12 thou. So we're on the loose side. Let's just check it in another spot here. Let's just go 9 o'clock. Zero out. Yeah, 12 thou, bang on. So I'm on the loose side of tolerance. Okay, so with enough dick around, I got it to 258 on the right side, and I got it to 272 on the left side. Yes. Perfect. As you can see, I marked my diff. I got 9, 6. Oh, I'm an idiot, aren't I? No, 9, 12, 3, and then 6. And what I did is I checked my backlash at 4 spots on the ring gear, and they're all the exact same at 8 thou. So that's on the tight side, but I'm going to leave it because the gears will loosen up a little bit as they get worn in. So the next thing to check is the wear pattern on the gears. So this is where this entire process can go all fucky, and I could have to start pretty much everything from scratch. So what am I doing when I'm checking the gear pattern? Well, I want to make sure that the pinion is about halfway, or sorry, is in the middle of this ring gear. I want to make sure it's not too far or too deep in the ring gear or too shallow in the ring gear. So how does this all be, how does the shims on the carrier versus the shims on the pinion affect this? So I put a 28 thou shim under the pinion bearing, and that pinion bearing dictates how deep the pinion is vertically in this ring gear. So imagine the pinion's here. If I put too thick of a shim in, it's going to push it right into the carrier, and if there's not enough shim, it's going to be pulled out. Versus shims on the carrier. So if you have too much shim on the left side, it's going to push the carrier into the pinion more. And that means the pinion is going to be very deep in the groove. Whereas if you don't have enough shim on the left side, it's going to pull the carrier away from the pinion, and the pinion's is going to be very shallow in here. Now that I've got my backlash set up correctly at 8 thou, dead on the tight side, as these gears wear in, it'll loosen up a little bit, that's fine. So with backlash now within spec, proceed to step 8. Remove 4 bearing cap bolts and 2 bearings. Why am I taking this all back apart? Okay, to establish differential bearing preload, increase both left hand and right hand differential bearing shim size by the thickness shown. I need to increase shims on both sides by 6 thou. By adding 6 thou onto each side, what that's going to do is press the bearing caps onto the bearings more. And because we're adding the same amount on both sides, that should not change the backlash in any way. I really hope it does not change the backlash in any way. Okay, since I need to check the pattern on the ring gear, I moved you over to the other side. Okay, so how do we do that? Well, the kit came with this here gear paste. That's all it is, just some yellow paste that you stick in there. I had a brush. What did I do with it? Oh, am I recording? I did record. I did. Okay, take 2. So what are we doing? We are about to check gear pattern. So I've moved you over to the other side so you can actually see what's going on here. So, got a brush. Got some gear paste. So what we're going to do, we're just going to paste this in here on both sides, front and back. As even as we can, top to bottom. So since this is all the 4 racing gears rebuild kit came with, I hope I only have to do this the once. I wouldn't have to adjust anything. That would be just fantastic. But no, that'll be the case, so it is what it is. Okie dokie. Okay, so looking at the instructions, the way I read this is this side is the drive side, the inside is the coast side, we've got the heel on the outside, toe on the inside. Load. Okay, so yeah, it says while turning pinion gear, rotate ring gear 1 complete revolution in both directions. Apply load with a large screwdriver or similar tool between the carrier casting and differential case flange. I don't know what the differential case flange is, but this looks good to me, and this looks like casting to me. So I'm not doing it on the ring gear. Interpret the pattern on the ring gear as shown in the following illustration. Okay, so that to me looks like the tires would be going forward. So I'm applying load as best I can at least. full revolution. Now we're going to go 1 full revolution backwards. Geez, what is this telling me? On the so did I say this is the drive side? So on the drive side I have full contact top to bottom on all of them. And then on the front side there on the, is that the coast? Yeah, the coast side I also have top to bottom full contact. So what does that tell me? I think that tells me that the pinion is too far in. Maybe. I don't know. What's this telling me? So it says the drive pattern should be centered on the tooth. The coast pattern should be centered on the tooth but might be slightly toward the toe. There should be some clearance between the pattern and the top of the tooth. So there should be some clearance between the pattern and the top of the tooth. There is no pattern between the clearance and the top of the tooth. So how do we fix that? So I think what this is telling me is I'm not too far left or right. The fact that I'm fully meshed top to bottom, I'm too far in. Maybe. Okay, so looking at this pattern, what do we have here? I found my pen. We have pattern from the very top to the very bottom, inside almost to the bottom, you know, right along the very top, and the same thing on the back side, very top to very bottom. So we actually want this pulled out a little bit. So I think what I want to do is I actually want to pull some shim out of the pinion bearing. I'm at 28 thou right now. Looking at this, I'm thinking like maybe even 20 thou. I mean, that's just kind of talking out of my ass, but that's kind of where I'm at. backlash good. It's definitely within spec. It's about 9 thou, so it's between 8 and 12 thou. That Ford Racing recommends. I have a very good pattern on the gear now. I think it should wear nicely. So yeah, so I'm taking this all back apart because now what I need to do is I need to get the setup bearing off of the pinion, and then we'll press on the new pinion bearing, and then this install is done. Put it all back together, torque it all up, and we should be good. What I absolutely want to do is, as I'm pulling this apart, I do not want to mess up the shims that go side to side. I want to make sure I keep the right side shims on the right side and the left side shims on the left side. If I mess this up, it's going to throw all my tolerances out of whack. Luckily I've got them all written down so I know where I'm at, so I could get back here if I needed to, but I don't want to do that. So I'm going to pull the shims out of one side, tape them up, clearly mark it, do the same for the other side, and then I'll keep them together in the box or something like that. Okay, so where are we at? Pinion bearing is pressed on. The way I did that is the setup bearing that I had honed out the inside. That's this guy here. I cut the cage off of it, and then in the press, this just goes upside down, pressed up to 6 ton, and it's installed. I've got the 28 thou shims in there already, so this is ready to go back in. So the next step, what we're going to do is we're going to put a little bit of grease just on the outside of the seal. We're going to knock the seal in because this is the last time that these bearings, or I don't need to set it up anymore. I just need to press the seal in, and then I am good to go. Before I do that though, kind of want to pull this bearing out, clean everything up, put it all back together. Okay, clean. done. Alright, so I looked it up and the tool to install is like 120 bucks. So we'll try again with the hammer. Got a little bit of oil on the inside here. And if it still doesn't work, I'll see if I know somebody with the tool. I don't want to spend $120 for a one-time install. A couple of YouTube videos, guys are able to get it in just with a small hammer, so let's just see if I can't do it. Gotta stop hitting with my purse. Okay, look at that. Because I stopped hitting with my purse and then easy peasy. So that's the seal. Next thing is to put a little bit of grease on the inside of the seal. I can see there's already a tiny little bit, so I'm just going to add a little bit more. Like, you know, that little tiny bit, probably more than enough. Piston up to the bottom, or pinion, not piston, pinion up to the bottom. Like we've done a million times. Like this, so we have a seal installed. Boom. Flange, boom. Brand new. So these lock nuts, or these nuts, are a one-time install only. There's this coating on the bottom, coating on the inside of the threads. They're designed to be used once and thrown away. I reused my setup one. You can see most of the material is gone. Nothing on the threads to lock it. Oh. Ooh, I almost messed this right up. I forgot one critical piece. Our solid spacer. That would have been bad. Off, as a good friend of mine once said, just don't have filters. Solid spacer shim. Let's clean this up a little bit. Okay. Pinion. And okay. Since I have the solid spacer in here, I should be able to impact this down, and it should be at the 18 pounds, which is where I'd set this up previously. The solid spacer means I don't need to torque this down incrementally until it gets to the right inch pounds. With the solid spacer, it should be there on its own. Okay, 16 to 28 inch-pounds of torque. I'm right at 28, dead on 28. Okay, so we're not measuring the initial force to get it moving, but the force when it's moving. You can see that's, you know, just under 30. If we go back the other way, we're, again, you know, just under 30. Going this way. Like dead on. Like this is, it feels tight, but it's perfect. Whew! I am pretty happy with that. Okay, so now we're going to flip this over and restart the assembly process. They want 8 to 12, I'm at 9.